Alright, introduction to cathodic protection, inspection, and testing. So, let's zoom in here. Alright, contents, inspection, procedures, and criteria. 1, 2, applicability. 3, criteria. 4, other consideration. 5, alternate reference electrodes. 6, testing. This publication is adapted from a unified facility criteria of the United States government, which are in public domain and have authorized unlimited distribution and are not copyrighted. Alright, 1. Inspection procedure and the criteria. Introduction. The discussion includes the criteria inspection action that when used either separately or in combination will indicate whether adequate cathodic protection of metallic piping system has achieved. 1.1 method. Effectiveness of the cathodic protection and other controls measures can be affirmed by visual observation measurement of pipe wall thickness by use of internal inspection devices. Because such methods sometimes are not practical, mean any criteria combination criteria in this chapter is evidence that the adequate cathodic protection has been achieved. When excavations are made for any purpose, the pipe should be inspected for evidence of corrosion, coating, condition, apply sound engineering practices, determine the method of frequency of the testing required for the safety of these criteria. 1.1.1. The criteria. The discussion have been developed through laboratory experiments, verified evaluating data obtained with a successfully operated cathodic protection system. Situation may exist with a single criterion. Evaluation of the effectiveness of the cathodic protection may not be satisfactory for all conditions. Often, a combination of criteria is needed for a single structure. 1.1.2. Corrosion and leak history. Available assessing effectiveness of the cathodic protection. Corrosion and leak history by itself, however, must not be used to determine the adequate level of the cathodic protection have been achieved unless it is impractical to make electrical surveys. 2. Applicability. The recommended practice is intended to serve as a guide for the establishing minimum requirement of the control of corrosion following systems. New piping system. Corrosion control by a coating supplement with a cathodic protection by some other moving method should be provided with the initial design maintained during the service life of the piping system unless the investigation indicated that the corrosion control is not required. Consideration should be given with the construction pipelines, manure facility, use of the inline inspection tools. 2.2. Existing coated piping system cathodic protection should be provided with a maintained unless investigations indicate cathodic protection is not required. 2.3. Existing bare pipe system. Studies show that made by determining the extent and the rate of the corrosion of existing bare pipe system. When these studies indicate that the corrosion will affect the safe economic operation system, adequate corrosion control measures should have been taken. Special considerations sometimes exist with the cathodic protection ineffective but only partially effective. Such conditions may include elevated temperatures, disbonded coatings, thermal insulation coating, shielding, bacterial attack, unusual contaminants in the electrolyte. A deviation from the recommended practice may be warranted in specific situations. 5. With the corrosion control personnel responsible, charged, and able to determine that the objectives expressed in recommended practice have been achieved. 3. Criteria. The criteria described above in accordance with the following National Association of Corrosion Engineers NAC standards. The recommended practice 0169 corrosion control external corrosion underground submerged metallic piping system. Recommended practice 0285 corrosion control underground storage tanks by cathodic protection. 0388 impressed current control protection internal submerged surface and sealed water storage tanks. Recommended practice 0193 external cathodic protection on grade metallic storage tank bottoms. Recommended practice 0196 galvanic anode cathodic protection internal submerged surface and sealed water storage tanks. Personal responsible corrosion control not limited with the criteria discussion. Criteria has been successfully applied with existing pipe systems. Will continue to be used with the piping system, and either with the criteria must achieve corrosion control compatible to attain with the criteria with this chapter. 3.1. Steel and cast iron pipes. Corrosion can be achieved with the various levels of the cathodic polarization depending on the environmental conditions. However, in the absence of the specific data demonstrated that the adequate cathodic protection has been achieved, one or more of the following shall apply. 1. 3.1.1. Negative cathodic protection. At least 850 millivolt with the cathodic protection applied with the potential is measured with the result of the saturated copper sulfate reference electrode containing the electrolyte voltage drops other than across the structural electrolyte boundary must be considered for the valid interpretation of the voltage measurement. No consideration is understood to mean the application of sound engineering practice to determine the significance of the voltage drop by methods such as Measuring, calculating the voltage drops, reviewing historical prevalence of the cathodic protection system, evaluating physical, electrical characteristics of the pipe in its environment, and whether or not the physical evidence of corrosion. 312. A negative polarized potential across the structural electrode interface with the sum of the corrosion potential cathodic polarization at least 850 millivolts relative to standard saturated copper sulfate references electrode. 313. A minimum of negative 100 minus millivolts. Cathodic polarization must be surface structure that's stable. The reference electrode containing electrolyte with the formation of the TA of the polarization can be used measured to satisfy the criterion. The criterion is not valid when bimetallic corrosion such as connective copper grounding is present. 3.2. Special conditions. 321. On bare and effective coated pipelines when long line corrosion is active, the primary concern with the measurement of the protective current at the predetermined control current discharge point with the electrolyte pipe surface at the measure. Either the current type technique must be sufficient. 322. In some situations, such as the presence of sulfides, bacteria elevated with temperature environments and dissimilar metals, the criteria paragraph 3 may not be sufficient. 323. When a pipeline is encased in concrete, buried dry, and aerated, high resistivity soil values less negative than the criteria paragraph 3 may be sufficient. Caution. Using polarized potentials less than negative than 850 millivolts not recommended with the cathodic protection pipelines. Operating pressure conditions are conductive with the stress corrosion correction. See reference for the stress corrosion cracking in the chapter. Caution to use excessive polarized metal potentials on coated pipelines should be avoided with the minimized cathodic disembowelment of the coating. 3. Coating polarized potential result of excessive generation of hydrogen should be avoided with all metals, particularly with high strength steel, center grade, stainless steel, titanium, and aluminum alloys, pre-stressed concrete pipe. Note the earth concurrent technique is not often meaningless. Multiple pipe right away is highly resistive surface soil with deep buried pipe. Straight current areas where the local corrosion cells are predominant. 3.3. Aluminum piping. The following criteria apply with a minimum 100 millivolt cathodic protection between surfaces and substructure surfaces and stable reference electrode containing electrolyte. Formation of decay polarization can be used with the criterion. Caution excessive voltage notwithstanding with the minimum criterion. If the aluminum cathodic protective the voltage is more than 1200 millivolt, negative 1200 millivolt measured between the pipe surface and saturated copper sulfate. Reference electrode containing electrolyte compensation made with a voltage drop off other than across the pipe electrode boundary and may suffer corrosion with the result of the buildup of alkali on the metal surface. The polarized potential may more negative than negative 12 millivolt should not be unless used previous test result indicate that non-appreciable corrosion will occur with a particular environment. Caution. Alkaline conditions. Aluminum may suffer the corrosion under high pH conditions. Application cathodic protection tends to increase the pHa of the metal surface. Therefore, careful investigation testing should be conducted before applying cathodic protection to stop pitting and attacking aluminum environments if the natural pH exceeds 8.0. Hard copper pipe with the following criteria apply with a minimum of 100 millivolt cathodic polarization between structure surface and stable preferences. Electrode containing electrolyte formation decay polarization can be used with criterion. Dissimilar metal piping. Negative voltage between all pipe surfaces and a stable reference electrode containing electrolyte equal to that required protection and the most anodic panels should be maintained. Hard caution. Atmospheric materials that can be damaged with a high alkalinity created with the cathodic protection should be electrically isolated separately and not protected. Alright, other consideration. Determine voltage drop. Method for determining voltage drop should be selected to apply using sound engineering practices. Others determined by voltage drop may be used with the correct future measurement at the same location providing conditions such as pipe, cathodic protection, operation conditions, soil characters, coil quality, coating quality remaining similar. Placing a reference electrode next to the pipe surface may not be the pipe electrolyte interface. The reference electrode placed on the coated pipe surface may not significantly reduce soil voltage drop in the measurement in the nearest coating. Holiday is remote from the reference electrode location. 4.2. Sound engineering practice. Where impractical, consider the necessary discurrent of all the current sources for the corrective of the voltage drop of the pipe electrolyte potential measurement. Sound engineering practice should be used to ensure that the adequate cathodic protection has been achieved. 4.3. Inline inspection of the pipe. Practically, inline inspection of the pipelines may be determined in the presence of absence, piping, corrosion, damage, Absence of corrosion damage halted in the growth may indicate adequate corrosion control of the inline inspection technique. However, they may not be capable of detecting all type of corrosion damage. With the limitation accuracy may report with the anomalies in its items that are not corrosion. For the example, the longitudinal seam corrosion, general corrosion may not be readily detected by inline inspection, but also possible thickness variation, dent, gouges, external various objects may be detected as corrosion. The appropriate use of inline inspection must be carefully considered. 4.4 Straight current, straight electrical gradients. Situation involving the straight current, straight electrical gradients may exist. They require special analysis. 5. Alternative reference electrodes. 5.1 Alternative to saturated copper sulfate. Other standard reference electrodes may not be substituted with saturated copper sulfate reference electrode. Two commonly used reference electrodes are listed below along the voltage equivalent of 75 degrees Fahrenheit to negative 850 millivolt reference saturated copper to copper sulfate reference electrode. Saturated KC saturated K, chlorine, calomel reference at 780 millivolt. Saturated silver chloride reference electrode, 25 ohms at centimeter seawater, negative 800 millivolt. Alright, 5.2 Alternative metallic material on structural additions for the standard reference electrodes. Alternative metallic metals material structure should be used in the place of the saturated copper sulfate reference electrode. Instability with electrode potential is that ensured in the voltage equivalent referred to as saturated copper sulfate reference electrode is established. Alright, 6. Testing. 6.1 Potential measurement. Cathodic protection must be tested as system function, troubleshoot inadequate performance. Potential measurement based on theory of the measuring unpotential by relating it to the known reference electrode principle test. Procedure used. Measurement is taken by connecting high resistant voltage meter negatively to the reference electrode half cell. Connecting the positive lead with the metal being tested, the reference electrode must contact the electrolyte that is in contact with the metal being tested in soil, freshwater, copper sulfite. Reference electrode should be used in saltwater. Silver chloride reference electric must be used. For erroneous reading, the voltmeter must have the minimum of the 10 million ohms input, with the resistance under normal conditions. Under rocky, very dry conditions, shall have up to 200 million ohms input resistance. Caution: if the voltmeter polarity switch, such as the MC and Miller Model B3 series or the D Arsenal movement needle deflects the positive direction, select negative. If there is no polarity switch, attach connections backwards negatively to the structure, positively to the reference cell. To prevent damage to the meter, then interpret the positive deflection as a negative reading. Alright, 6.2 Sources of error. The 5 sources of error was when taking a potential measurement of structure accuracy with the reference electrode. An IR error representative of the current is flowing and present when the current is flowing. Anoid gradient field present when the current is flowing. Contact resistant error with the reference electrode is not in good contact with the electrolyte. Influence of foreign structure makes potentials. Alright, 6.2.1 Accuracy of the reference of electrode. Prevalent erroneous potential measurement with the accuracy of the reference electrode with a half cell must be reliable. Valid tested reference electrode must be used at all potential measurement of the proper mate with a half cell with essential electrolyte and the half cell contaminated. Or metal electrode is contaminated or oxidized with the potential cell charges. Temperature also affects the potential reference cell. There's an increased proximity of 0.9 millivolt per degree Celsius would read, so a measurement of 0.8, negative 0.85 at 70 degrees Fahrenheit would read a 0.835 at 40 degrees Fahrenheit and a 0.865 at 100 degrees Fahrenheit. Determining the accuracy of the reference electrode. Multiple reference electrodes must be used in practice. They should be one reference electrode maintained properly when not used in field. Check with the other reference electrode against before they are used in the field. This reference electrode must be properly initiated and stored. Alright, 6.2.1.1 Initiation reference electrode. Copper sulfite reference electrode must be properly cleaned, initiated, ensure accuracy and proper cleaning, and limit initiation of the cause of significant potential reference subsequent errors in all measurement taken. The metal electrode must be cleaned properly. Electrolyte solution must be prepared properly to ensure accuracy. Alright, the figure 1 shows the copper sulfite reference electrode half cell sealant, top cut, O-ring, copper electrode body, copper sulfate, Z-ring, cone and plug. Cleaning. Clean the metallic electrode thoroughly with the use of non-metallic materials. Do not use metallic sandpaper grinders, emery cloth, wire brushes, knife blades, any other metallic cleaning method. For example, aluminum oxide sandpaper with deposit particles, aluminum on the copper to wire brush with the deposit particles of steel on the copper, the change of the potential of the electrode. Proper way to clean a copper electrode is non-metallic sandpaper. With non-metallic sandpaper is over the flint of the paper and the cloth. All copper oxide green color must be removed from the electrode and shall be cleaned with a shiny no pitting. If the electrode is prided, accuracy with the question should be replaced. Preparing the electrolyte solution. Electrolyte must be filled with a saturated solution with a copper sulfate, half body cell body through thoroughly cleaning your eyes over several times distilled water before mixing solution a half cell. There should be approximately 1/3 of the volume of the copper sulfide crystals installed with a half cell, with the remaining volume involved with distilled water. There are not more any copper sulfide crystals in the threaded area of the half cell, and they can be accomplished by adding the distilled water to the threaded area while rotating a half cell. Proper solution of the dead blue in the color. After vigorous shaking, there must be some copper sulfate crystal that will not go in the solution fully saturated with the half cell that has been previously used. Additional steps are used in all parts of the inspected cracks or defects. O-ring shall be replaced. The cone of the plugs must be replaced to provide additional protection on subsequent leakage. Electrolyte half cell with the plumber shape that can be used on the threads of both top and the end cap. New or used half cells. If the copper electrode removed the end cap, replacement of the end cap is required. The threads must be sealed with the proper sealant. Will be reinstalled to prevent leakage electrolyte. Hard testing. Determine the accuracy of the half cell. Use the multiple reference electrodes. Use the reference electrode. Measure for the difference potential half cell. Unders test. Use the meter with a pilot millivolt scale. Place 2 cells cone to cone. Measure the potential difference. Potential difference should not exceed 5 millivolt. Reference electrode is available. The following procedure: 7211 for initiating reference electrode. On new use half cells, reliable reference electrode test potential difference in millivolt. 2 other cells, reference electrode first initiator allow with sufficient time to come and become saturated up to 2 hours. Placing half cell come down in the container of the copper sulfite solution can be speed up the process. 622 IR drop, which would be your amp on resistance. The amp on resistor drop error code with the cathodic correction following with electrolyte. A resistor error is greater than current. The resistivity is higher. The distance from the reference electrode structure higher than the well-coded pipeline, with the distance nearest holiday is greater. Instant off the amp free potential measurement will remove this error. The error is negative direction. With the example, the error you measure is 0.85 volt DC potential. After correction, the error you may actually have negative 0.75 volt DC. Alright, show the voltmeter positive and negative reference electrode, current flow, resistance, and current. The IR drop. 623 anode gradient error. The voltage gradient with the anode causes the error with an anode connected with the circuit during the test. Current design with the error the greater with the voltage anode is high with the distance of the reference electrode. Anode is short with the cathodic protection circuit. Resistant number of the anodes of electrode resistivity effect of the anode gradient field size. Anode gradient is larger than circuit resistance is higher because of the high circuit with the resistance high swell. Resistivity low, number of anodes being spaced too close together, placement half cell major factor to determine the true potential of the structure. Impressed current system anodes with not truly in the remote area with the mixed potential reading of the structure being tested. The anode potential taking potential measurement of the anode in the circuit and an instant off and potential measurement. Remove any possibility of the error. The error is negative direction. For example, the error we may measure 0.85 DC. After correction, the error may have 0.75 volt DC. So it shows voltmeter from positive to negative, the reference electrode, and rectifier positive and the negative. 6.2 contact resistant error. With the poor contact of the reference of the electrode with the electrolyte result error of the contact resistant half cell with the earth with the problematic under rocky dry conditions. Apply with the water on dry ground and use very high resistant voltmeter. Cathodic protection voltmeters have selectability input resistance to 1 million to 200 million ohms. Normally 10 million ohms is selected. Scale will take potential measurements of the input resistance of the next higher selection. Reading that does not change. Contact resistance is significant. If the reading does not change, select with the next higher input resistance. Continue until the reading does not change with the high selection. Still change the reading. Add water and retest. Error in the positive direction. For example, when the error you may measure 0.85 volt DC after correction error, you may actually have 0.95 volt DC. Input resistance measurement used must match greater than the contact resistance accuracy measurement. Figure 4 shows contact resistance error, the voltmeter, the low internal resistance reference electrode, high external resistance in the pipe. 625 mixed potential error. Error result of the potential measurement being taken with the structure of the mix with potential other structures also connected with the circuit being tested. The error is significant with the coating of the structure being tested is very good. There are other structures that are not isolated from the cathodic protection. The error is present when the system is being tested is not isolated greater than when the condition of the coating is better with the distance of the nearest holiday. It was greater with the distance half cell with the other structure is shorter. When the coating of the other structure is worse or bare, when the negative potential of the other metal is negative, more cathodic in such copper error is usually positive direction. For example, you may measure negative 0.85 volts after correction. You may actually have negative 0.95 volt DC. Error can be then in negative direction contact and the more negative, more anodic metals such as aluminum, zinc, galvanized steel measurement, magnesium. Some of the steel was in the stainless steels in the passive state. Another source of more positive mixed potential cause small anodic area structure being tested, large cathodic area, same structure, influence potential measurement. Area is greater than the size of the more positive area with a smaller distance to the reference electrode of the structure is greater when the size of more negative area is greater. Figure 5 shows mixed potential area with a red pipe and the voltmeter and positive and negative of the reference electrode, foreign structure, metal contact. Part 6.3 Practical measurement, cathodic protection potential test criteria selection. The method of the potential testing varies widely. The different type of the structure with the different criteria of the evaluation of the potential taken. Sometimes different criteria may be with the different areas on the same structure. The criteria selected depends mostly on the type of the structure, isolation, non-isolation, structure coding type, the efficiency type, cathodic protection system, soil resistivity, amount of the current supply by the CP system, instrument available for testing, sacrificial cathode protection system. Shown the criteria for the sacrificial cathodic protection system is 0.85 on and ampere resistant. Ampere air must be compensated with a usable placing of the reference electrode in the area of the structure as possible directly over the pipeline or tank, as remote as possible. The sacrificial anode combined with the knowledge of the structure coding, soil resistivity, size and spacing, anode current, usually enough to determine the accuracy of the cathodic protection applied to the structure. In doubt with the potential reading questionable, act as excavate to allow placement of the temporary reference electrode, permanent reference electrode that is close and practical to the structure for the firmer, minimize as possible IR error. Some sacrificial systems now are low resistivity and low ampere error, well coded errors, low current requirement, low ampere error because of the very small driving voltage under 1 volt, have very small in current flow, low ampere error. The dielectrical strength of the structure coding of the not good for the soil resistivity relatively high, locational spacing anodes making it possible to measure structural potential remote with the anodes. Other criteria should be used. Excavations may be made to properly place the reference electrode to obtain the valid potential measurement for very small, well-coded such valves, elbows, and tie-downs. Use 100 millivolt polarization criteria for official sacrificial system. Sacrificial system designed to allow interpreting of the current from all anodes simultaneously at negative 100 millivolt polarization criteria caused by 0.85 instant off criteria. Use not attainable to moist soil conditions. Sacrificial anodes unless the negative potential of the structure is very high and soil resistivity is very low. The negative 0.85 instant off criteria should not be used in sacrificial of the cathodic protection systems, except in rare cases. Use 100 millivolt shift criteria for the using or the negative 0.85 on criteria considered ampere ohms. Alright, 631, impressed current cathodic protection. First consideration determine criteria for the impressed current cathodic protection system. Type anode bed use. From disturbed anode impressed current system of the 0.85 instant off the 100 millivolt polarization criteria showed be used at negative 0.85 on criteria should be not used. Structures with a high dielectrical strength coating. The negative 0.85 instant on off, since our instant off criteria may be easiest to use, although 100 millivolt polarization criteria can be used. Structures where bare poorly coated with a deteriorated coating 100 millivolt polarization characterization should be used. For remote impressed current system, all criteria with a mixture criteria with a maybe with the anode of the true remote with a test. Yeah. I'm alright, Mama. Yeah.
You gonna starve later?
No. I'll make a sandwich. Alright. For remote anoid and press current system, all criteria and all mixture criteria may be used with the anoid is truly remote, with the test point with the electrolyte relatively slow, with the dielectrical strength of the coating is high, with the circuit resistant cathodic protection system is low, with the negative 0.85 on criteria to conserve the ampere ohm error is sufficient according to the voltage drop, other than the across the structural electrolyte boundaries, usually accomplished by placing reference electrode near the structure as possible directly over the pipeline tank of the combine. Knowledge of the dielectrical strength of the structure, coating of the side of the structure with electrolytic resistivity, distance, voltage with the anoid of the rectifier output voltage, rectifier output current, usually enough to determine the adequacy of the cathodic protection system applied with the structure. No doubt, if in doubt, when potential readings are questionable, test location and other criteria. Excavate, locate temporary reference electrode, install permanent reference electrode as critical to the practice of the structure. Further minimize as any possible amp error for structure's dielectrical strength coating, regardless for the electrolyte resistivity distance for the anoid cathodic protection system's circuit resistance of the negative 0.85 instant off criteria that may be used, although the 100 millivolt polarization criteria may be used for structures with their poorly coated, heavy deteriorated coating of the 100 millivolt polarization should be used. Our 632 testing method is for the negative 0.85 criteria. Single electrode potential is conducted with a very high impedance for the high input resistant voltmeter 10 mega ohms or higher. The voltmeter positive negative structure under test voltmeter negative the reference electrode display with the proper polarity of the angle. Analog meter for the only read with the positive direction. The leads must be connected backwards to get unscaled deflection. Negative value must be inserted when recording measurement. Negative 0.85 volt DC is measured to the copper sulfate reference electrode half cell. Other type of the reference electrodes must be corrected with the copper sulfate reference at negative 0.84 volts criteria. Figure 6, single electrode potential survey testing station, wire reel, insulated wire voltmeter, intervals 1, 2, and voltmeter reference electrode. Since the potential readings are taken with the cathodic protection current onto the air with the measurement with the conservative to obtain with the valid conclusion of the adequate cathodic protections if the protection structure captures 6 of the handbook of the National Association of Corrosion or NACE International Record Recommended Practice 016992, Section 6.22, steel and cast iron pipe stay with the voltage drop of the cuff of the structure of the electrolyte boundary must be considered with a valid interpretation of the voltage measured with the categorization understand with the application sound with the engineering practice determine the significant voltage drop. The methods such as measuring, calculating voltage, reviewing historical performance, cathodic protections, evaluating physical electrical characteristics of piping of this environment, determine whether or not physical evidence for the corrosion. All the errors in the above of the evaluated interpretation for the cathodic protection current does not fall under the criteria with the strength that would be pertains to negative 0.85 instant off the 100 millivolt polarization criterion. Measuring and calculation voltage drop that include the measuring all factors magnitude voltage drop voltage errors present of the on reading the measurement include with the anoid output rectifier current output structure coding efficiency location reference of the cell with the relation for the anoid with the structure electrolyte resistivity comparison with the previous potential native on and or instant off the other factors that may be contributed with the corrosion presence of the straight current interference by bimetallic connections, pH, temperature, homogeneity of the soil, with the amount of the oxygen presence of the bacteria, presence of the other ions, contaminants, which may affect the corrosion rate, implementation of the criteria, only possible when the factors quantitatively verified with measurement of the factors with the historical evidence of the factors having considered the facts of the degree of the magnitude, voltage drop across the other slow and stop the corrosion rates include hydroelectric strength coating with the 99% of the 99.7% effective coating drastically lower the amount of the current to obtain with the adequate quick cathodic protection. Consequently, the ampere error is also dramatically lowered. Low electrolyte resistivity allowed by the ampere drop, the error lowered and press current system on the circuit is resistant of the resulting lower voltage of the anoid to the obtainment of the same current with the lowering of the anoid gradient. Errors. High pH of 7 to 13. High pH electrolyte near the protective structure indicate the cathodic protection present for the atmospheric materials could be damaged by high alkalinity created by cathodic protection. Low temperatures which decrease the corrosion rate, current density, lack of the bimetallic connection present with the wood rate with the corrosion rate. Lack of interference, corrosion, interference ready for the potential for the backup. Pick up the air, lower corrosion lowers with the potential of the discharge, increase with the corrosion rate. 633 test method of the instant 0.85 instant off criterion. For the criterion measurement, the potential must be taken with a non-cathodic protection current with the following. Measurement of the instant off of the potential with the cathodic protection is now flowing required with the means of removing the errors from the measurement with the various methods for the measurement. The instant off potential, see paragraph 3.5. Potential measurement exceeds the negative 0.85 volt DC in the comparison of the copper sulfate reference electrode using the method. This criteria has been met. Other reference electrodes must be corrected to the factor for a copper sulfate reference valid with the criteria. Test method, the 100 millivolt voltage polarization criteria. The test of the method of the criterion is exactly like the method of the negative 0.85 instant off criteria with additional requirement of comparing the measurement of the native survey potential taken by the cathodic protection current was applied along with the measurement of the polarization decay is recommended for the native potentials or to compare the instant off readings of the 100 millivolt polarization criteria that after the cathodic protection is applied. The structure of the polarization after the current interruption, consider time of the required before the potential return of the native potential value. Measuring polarization decay is guarantee the proper shift that may require considerable more current polarized structure level than 100 millivolt. Depolarization would occur with a relatively short time. Alright, 635, instant off test method. The test method of the instant off potential measure the term of the type of the equipment that with the type of the current interrupter with the test method include with the interrupter with the protective of the current measurement of the potential for the no current flowing with a guarantee of the relative of the all amperage the N gradient air of the four different equipment, the technology of the U of the sum of the wave of the accomplished for the current interruption, sometimes depending on the type of the equipment being used, the type of the equipment include the normal high impedance. Digital voltmeter may be used with a combination of the conventional current interrupter with the manually with the synchronizable with the advanced synchronizable interrupter not pole for the generators using unless you have the conventional interrupter with the data logger which record the potential measurement very quick from the force level to 1,000 readings per second. Maybe you with the combination conventional current interrupters may be synchronized with the advanced synchronizable interrupter of the not pole of the generators and left the other conventional interrupter for the analyze of the data. Sometimes you with the computer software determine the instant off potential reading waveform analyzer maybe you with the pair together with the cells generate with the calculate the off potential high speed data logger oscilloscope similar with the high speed with the reading recording device maybe you with the analyze of the unfiltered signal of the structure to obtain with the potential structure when the DC output waveform is zero current output and the technology may be only applicable to the potential measurement of that affected by only one single phase rectifier. The filters and choke disconnected from the rectifier output that may remove the anoid gradient errors. 636 type of the interrupter depending on the number of the rectifier, the DC's current source, of the type of the equipment you will perform the instant off measurement, the manual interpretation of the cathodic protection rectifier without using AC power switch rectifier or circuit breaker or other means that generally not recommended. With the timely manual with the open and closed contacts coupled with the interpretation of the AC side of the circuit does not provide adequate repeatable measurements under many conditions for a second interruption. Resulting in significant inaccuracy with the measurement obtained with the manually operated relay. Contacts are sometimes used may produce repeatable results if they are quick open and closed mechanisms are installed with the DC output rectifier using radios to signal operators to open and close contact breakers switches and could be used on errors reading due to RF signals, radio frequency signals from the radio that may induce voltages into the meter being used record measurement, especially analog meters, unfiltered digital meters. 6361 conventional interrupter. The conventional current interrupter provided with the interpretation rectifier DC output current with normally accomplished by opening the circuit either by an anodes rectifier or the structural rectifier, usually unit number for the independent control open with close time and the variation of the accuracy of the interpretation time current rating of the relay contacts selection increments on and off cycle will vary between the units of the use of the normally installed temporary rectifier output of circuit during testing, but sometimes optional installed with the rectifier cabinet cohorts crystal control. The units are usually accurate to the 1 second of the day. Within 1 second of a day. These units are typically powered by batteries installed internally with external DC power source through a panel plug. 6362 manual synchronizable interrupter. The unit with a cylinder with a high quality conventional interrupter may accurate with 1/10 of a second in 24 hours. The added Additional feature for the synchronizing interpretation cycle with while others like units that are normally accomplished by a sample supplied cable to temporary current connection. Two units together to start in third, fourth, and etc. for the synchronization interpretation cycle with all of the units are if possible. Interpreted several of the rectifier simultaneously various interpretation instruments to maintain an instant all of the potential reading. Usually portable, but it could be possible to install with equipment with a portable unit with a synchronizing rectifier installed. Our 6363 Advanced Synchronizable Interpretation, the unit similar to the manual synchronizing interpreted mean with the synchronization control with some of the communication technology versus manually with a cable connection such as radio, computer connection, modem, satellite transmission, usually permanently with install with a portable unit that is also available. 6364 pulse generator. The pulse generator can be normally be used with a conventional current interpreter up to the standard pulse generator. This may be permanently with a temporary. Install with the rectifier equipment that do not require the synchronization unit to proper very form the analyzing equipment. If the use of the conventional current of the interpreter they even do not synchronizable are used and provided with the user selectable interpreter. Cycle with the chain pulse generators connect with the series with the DC output with either positive or negative error with the rectifier produced with the precise time. Zero current pulse with does not drive the AC supply voltage with the power pulse generator with the selectable AC power units must be set in for correct AC supply voltage being used to ensure the pulse generator is proper. The voltage provided AC power with the pulse generator will be damaged. 637. The specific method of the various instant off potential measurement techniques using normal to digital voltmeter with the current interrupt with the digital voltmeter may be used together with the current interrupter to measure an instant off potential for the location effect of more than one DC rectifier or DC current source. Synchronized interruption must be accomplished for locations that affected more than 3 to 6 rectifier DC current sources according to their contribution availability. Synchronizing interpreters subsequent systems can be turned off precluded that the contribution instant is off reading. Alright, then it shows the figure 7 shows the typical display readings of the digital voltmeter, negative volts, 0 to 1.2. Interrupter segment 1 second off with the 4 seconds on the number of readings in the quarter second intervals. Our limitation meter for the needle valve needle to display with the measurement of the D of our savannah measurement movement preclude with the U of the application for the needle swing with a relatively slow movement which may be slower than the initial depolarization which occurs after the interpretation time when the needle switch catches up with the actual measure of potential significant depolarization may have already occurred. U of the technique with the yield of the measurement value with the actual instant off the wedge. Which can be measured by using method of the typical digital voltmeters, taking hundredths out of the reading of the second with the normally update with the display almost after the change of the reading, or about every 1/4 of the second under. Consequently, change the condition of the actual instant off measurement must be determined viewing with the digital display with an actual manually recorded measurement sensibly display with the update with the only after the change is only updated after 1/4 second under the change of the condition with the display must be interpreted. Normally, the display with the constant is not changing while the current is interpreted. The meter may recognize the change with the average measurement update with the display. First blink contains the average of all on and all off, and any other spiking other positive negative, which has occurred since the last display updated by 1/4 of a second with the first blink with the off, and the inconstant part with the on should be discarded. Second blink of the off measurement should be recorded. This number of the one displayed about 1/4 of a second which watching display through several interruption circuits may be required. Interruption cycles may be required to ensure the correct value of the recorded. Value recorded using the technique will have about 1/8 of a second or just under 1/2 a second of the depolarization. Some of the digital meter's memory function will remember the minimum, maximum, on, off, instant on, and instant off the readings of the meter technology. Meter can toggle between the two readings. The use of the type of the digital meter with the interpreter in a short off cycle. Usually 1 second the meter can be reset on and off, and on can be then reset the on and instant off the display recorded. The recording using the technique will have 1/2 to just 1 second of depolarization, 1 second off cycle. Some interpreters are available which capability half second off cycle which could be used to obtain approximately the same accuracy. Previously method 1/8 of a second to just have under 1/2 a second of depolarization. The occasions are significant depolarization maker over the time recorded with the method obtained with the instant off reading with the speed of the depolarization depending on the type of the coating, conditioning of the coating, the electrical strength of the coating, the current density of the tip of the electrode, minimum negative volts, maximum recorded positive interrupter second, 1 second off, 4 seconds on, number of readings 1/4 second intervals. 6372, using the data logger with the current interrupter for the digital indicator for the current interruption required with the data logger record with the 4 to several thousand for the readings per second for the measurement taken not on average over the time. As with the digital meter, locating being tested the measure with at least one off cycle with an instant off reading with extracted manually with the data with the extracted V with the computer program designed for that purpose. Positive with a negative spike when the may occur with the current interrupted with which goes back on should be disregarded and not considered the valid instant off reading for data loggers may record more data, resulting in high accuracy without the required more time in the Explorer. The current reading very fast data loggers may require software analysis. The data get into instant off reading with a timely manner, manually verified with the representative with a sample of the data to ensure the software is effectively explorating the current reading value recorded with the technique will have with about 0 to under a quarter second of the depolarization recording sample speed with the data logger, if possible 4 speed, 4 readings per second with the record positive and negative spike with the 1 over the readings depending on synchronization timing, sample timing data logger indicate that the next reading would have a quarter second depolarization. Figure 9 shows the voltage spiking on the instant off readings. The on off positive spiking can affect with the instant off reading negative voltage negative spiking. 6373 using waveform analyzer of the poles for generator of the wave and analyzer of the microprocessor based on a handheld voltmeter using the complex computer algorithm to measure on instant off potential to accurately with the calculate off potential of the pulse generator that must be installed with the rectifier with or DC current source that affects the location of the measurement being made with the pulse generator interprets the output of the rectifier within the precise timing cycle. This interpretation generates precisely time zero with the current pulse with required with the waveform analyzer to accurately calculate off potential. Pulse generators do not require any synchronization. Waveform analyzer capture the digital posture of the potential waveform by recording 1000 volts reading with the waveform digital signal processing techniques often use to filter out any induced AC or 60 cycle noise in the waveform of the on potential reading of the calculator. The error from the 6-pulse generator that having the greatest influence on the reading to determine and analyze zero current pulse. All pulse generators affecting waveform on the off reading of the potential calculator subtracting the error on the on reading. If the location under the testing should have more than 6 rectifiers or DC current sources significantly affecting the potential, separate testing should be conducted. Verify eliminate possibility if there are more than 6 sources of the current affecting the potential particular location. Determine the 6 sources of the greatest influence and determine the rest of the on so that their effects is not considered as part of the off potential value recorded. Use the techniques that were very little to no depolarization method. Measurement. Alright, 6374 using high-speed data log of the filtered oscillope. The oscillope U with the analyte with the rectifier output volt waveform high-speed data logger U with the obtain with the digital picture potential signal with the truck with the technology simultaneously measure with the rectifier output wave form and potential waveform in comparison with the pole 8. Some of the potential measurement of the rectifier waveform of the zero current. The technology may only be applicable to the potential measurement that are affected by only single phase rectifier with all filters choked with disconnect with the rectifier output. So the data logger of the connected with the truck with the closed circuit with the anodes through this rectifier of the potential anodes cause still affect with the potential measurement of the reading of the tank of the vicinity of the anodes on well-coded truck with the distance required with the removal of the possibility of mixing potential anode structure be greater. This technology will not work with the three-phase rectifier system or will have more than one rectifier potential structure. 6.4 structure soil potential limits. 6.4.1 except for the cathodic protection current. So the cathodic protection current produced with the hydrogen gas evaluation surface over the cathode with the gas surface produced faster than permeate with the coating of the bubbling with the coating of the curve with the amount of the coating damage of the dependent on the amount of gas generated with the type of the coating addition with the normally called blowing off of the coating with the curve of the mode structure with the exposed with the electrolyte with the trick with the resistance between the anode with the cathode becomes larger with the cause of the more current with the impressed into the location, usually more gas value evolution. This phenomenon result of the coating damage verified dimensional current distribution since more coating current goes to that location, less current goes to the other remote locations. Or 642 water storage tank. Coatings with the water storage tanks are more prone to damage. The type of the coating disbond with you very easily compared with the coating with the underground structure. The uncommon for elevated with the ground level the water storage tank. They have coating with bubbles blown off with the excess of the cathodic protection. Essentially of these tanks maintain level of the current at a safe level accuracy, permitting the reference of the electrodes using the automatic system whether there should be conformance concerned with the performing the cathodic protection system check for the on potential for the coated water storage tank have many error measurement the paragraph 2.3 on potential measurements of the 1.1 negative volt DC copper sulfate reference electrode suspected coating damage and instant off potential taken for the coating damage expected with the potential measurement of the over the negative 1.5 volt DC copper sulfate reference electrode instant off. The potentials must be taken. Instant off potential should not exceed negative 1 volt DC and must not exceed negative 1.1 volt DC copper sulfate reference electrode. 643 underground structure coating for the underground structure to be generally resistant with the damage on potential for the underground structure that have many errors in measurement. Paragraph 2.3 on potential measure for the copper solve with the reference electrode suspected coating damage over the potential for the table 23 suspected column and instant all potential should be taken with the current coating damage for the should be expected with the potential measure for the over taken the potential listed for the table 23 expected column. Instant all potentials must be taken with the figure assumed by the amper droppage error with the given with the formation of the only true with the measurement of the positive damage error free with the paragraph 3 instant off measurement should be used whenever possible. Instant off measurement that they are over approximately negative 1.22 volt DC are not theoretically possible. Instant off readings are significantly negative 1.22 volt DC to DC current. Sources are present with a synchronizing interpretation. All sources of current must be accomplished for fusion bond coatings. Instant off potential should not exceed 1.07 volt DC should not exceed negative 1.12 volt DC copper sulfate reference electrode. For gold tar coatings, instant off potential should not exceed negative 1.12 volts DC, must never exceed 1.2 volt DC copper sulfate reference electrode. For the basic and plastic tape coatings, instant off potential should not exceed 1.02 volt DC, should never exceed negative 1.07 volt DC copper sulfate reference electrode. For other coatings, refer to specification cathodic disbondment properties compared to the above coatings. Alright, 644, uncoated structure. Uncoated structure with no theoretical potential instant off reading with negative 1. Generally waste power anode material. Instant off measurement approximately 1, negative 1.22 volt DC are non-theoretical possible. Instant off reading with significantly over negative 1.22 volts or other DC currents supports are present. Synchronizing interpretation all current sources must be accomplished. Alright, shows your coating damage suspected and expected average soil resistivity at 2,000, 3,000, 5,000, 10,000, 15, 20, 30, 40, 50, and 100,000. And that's your potential limits on ground coated structure. Alright, 6.5 to cell-to-cell potential testing procedure. Performing tests, cell-to-cell potential testing performed to determine the direction current flow over the earth, especially over the unprotected pipeline located with the anodic area of the pipeline, pursued with the protected structure, unprotected pipelines over the cathodic protection, complete line with non-feasible economically hotspot protection, sometimes over the test procedure, with identify anodic areas of the pipeline application of the cathodic protection. Those locations over the polarity voltage difference between the two reference cells indicate the direction of the current flow. Accuracy of the reference electrode half cells used with the take of the cell-to-cell measurement must be determined. Perfect matching for the two reference cells of them non-essential, but the error must be accounted for in all measurement. The take of the accuracy of the two half cells of the term of the measuring the difference potential between the 2.5 cells being either the test use suitable voltmeter with the millivolt plate for the two cells cone to cone measurement the potential of the difference. The potential different should not exceed 5 millivolt, but if there's no reference, the reference of electrode with the file paragraph 2 to 1 on new use half cell with the get reliable reference electrode with the test the reference difference in millivolt to the other half cell reference electrode first initiated with the time during most allowed with the cone with it becomes saturated. The process that takes up to 2 hours must be sped up with placing half cell with cone down container of the copper sulfur solution paragraph 2.1 procedure checking with the reference electrode. Figure 10 shows positive the reading of the for the cell-to-cell survey shows current in the flow of the direction of the anodic area of the pipeline. Reference electrode 1 voltmeter, positive negative electrode 2. Alright, figure 11 shows the reference electrode voltmeter current flow in the direction anodic area of the pipeline. Reference electrode. Alright, 6.6 rectifier efficiency testing program procedure. Determine efficiency of the rectifier. Determine the measuring output voltage, output current with the calculating with the input watts using the following formula. Output rectifier efficiency is equal to output current times output voltage and input watts. Input watts are revolution per hour. The kilowatt hour meter disc X factor shown in the face of the kilowatt hour meter. 6.6.2 alternate procedure. The alternate procedure to gain the input watts simply measuring the AC input voltage input current Using accurate clamp-on ammeter with a disconnect with the measure AC amps for the appropriate procedure similar to above the measuring AC voltage. The method neglects the power factor will not truly accurate will give them a reasonable approximation. If the method used with efficiency testing should be done with the same error that obtain comparable rights. Rectifier efficiency is output current times output voltage over input current input voltage. And this shows that 12 of the rectifier efficiency, all full rated at percent efficiency, full rated at current. Negative 10% value with a fully rated at 40% efficiency. 663 expected efficiency. Expected efficiency rectifier depends on the type of the AC with a single three-phase, with the type of the rectifier element, with the cellular silicone, type of the rectifier bridge or center tab, the percent load of the unit with the cellular bridge rectifier with the most common unit cellular inherit with the less effective due to the voltage drop rectifier element resultant heat with the cellular age of the time when it becomes less efficient with the time passes. Alright, 6A with the dielectrical testing procedures. The short dielectrical adversely affect with the operation of the cathodic protection system. Cathodic protection system is designed with a particularly isolated structure for the shorted dielectrical with normal resolve loss, adequate protection with the short, but the structure of the short may also resolve with a poor correct distribution. Shielding will resolve with loss, adequate protection to areas of the structure tested insulated dielectrical present. Several methods, several types of insulation normally include many dielectricals, all of the parallel circle the failure than one. Dielectrical can effectively short the other in the entire system. The indication of the shortest condition of the dielectrical of any of the other all dielectricals install. You further distance between the dielectrical being test the dielectrical that is shorted, the easier of the test for the dielectrical. Most method of testing dielectrical given the reliable indication one condition of the dielectrical either shortened or non-shortened condition. Further testing may be required other condition. Only one method give the total reliable indication of the installed dielectrical. Radio frequency testing insulated with the flange tester because of the wavelength and the strength of the signal give it the two. True indication of the condition, specifically the dielectrical method, will not read through the other parallel path, even in the path of the immediate vicinity. In fact, the method of the can pinpoint with the valve of the particular flange bowl with the flange gasket. Therefore, message you the testing of any other method if it is not conclusive of the preferred method to determine the dielectrical may be shorted by prudential testing. The method is normally provided with the immediate function of the dielectrical, not short of it, sometimes provided with a variable potential data with the method indicate that the dielectrical may be short with the other method verification are required. Radio frequency tester installed with the flange tester should be used when a short condition is indicated potential measurement. Alternate methods verification may be used with the test and install the dielectrical. The methods include the pipe locator method, which determines the insulated dielectrical is bad, but does not give a conclusive evidence test and give the dielectrical is good. The power supply method, which can determine the insulated install the dielectrical is good, but does not give the conclusive evidence. It does indicate install the dielectrical is bad. Caution: do not use anemometers for measuring resistance if the install of the dielectrical. The dielectrical good current will flow through the meter, but the damage could result. If the current does not damage the meter, the measurement would indicate the resistance value. The voltage would interpret the measurement of it as coming from the internal battery installed with the external electrical circuit being measured. 6-7. Testing a for shorted dielectrical to measure measurement with both sides of the installed dielectrical chain with the other structure connection. Moving copper sulfate references. Test station metallic contact to pipeline hose side of the dielectrical positive 1, 2. Negative reference electrode street side dielectrical. Figure 13 shows testing shorted dielectrical. Or if the potential measurement is significantly different than 10 millivolt over 10 millivolt dielectrical, the street side of the dielectrical under normal conditions with the cathodic protection should be potential more greater than the negative 0.85 volt DC. The house side of the dielectrical should be between the negative 0.15 volt DC and negative 0.145 volt. Difference between 400 and 700 millivolt. The dielectrical good for the house side of the dielectrical potential more negative. Expecting another short of the dielectrical in area should be suspected. Further investigation is required. For example, the house side of the potential reading is over the negative 0.65. The street side potential same or more negative. If the two potential measurements are not significant under negative 10 millivolt for the dielectrical, may be short. Additional testing is required, and preferred method is use the radio frequency tethered insulated flange test. The test of the specific dielectrical unbasable method may or may not be conclusive. Include the use of the pipe locator or power supply method. 672. Using the radio frequency tester. The method of the most accurate with the conclusive method of testing dielectric. Turn off the insulated flange tester switch. 0 with the turn of the current knob. 0 with the needle indicator. Turn the test switch to the test without turning the control knob. Test the dielectrical. Show that it says the insulated flange tester. The insulated flange testers. 673. Using pipe locator. The two different types of the pipe locators indicate with the dielectrical bad. One short wave wavelength. One single form and press current. 60 cycle noise. Method can be used only with the impressed current system and the single phase rectifier. These methods can be rapid indicator the dielectrical short may not be conclusive. Figure 15 shows the testing short dielectrical use of piping locator signal and if required signal generated testing set caliber pipe locator signal. The pipe horn model FDA AC 200 deck tech signal single phase rectified with the impressed current system located with the UV of the following underground pipeline. The electrical short with the current sufficient locator will follow with the signal across the dielectric. Consequently, the signal is followed through dielectrical is bad with no signal that can be followed with the verified with the insulated flange tester. Short weight of the length of the pipe located with a direct connection to detect the signal from the signal generated with the obtained with the short signal with the ensure the good pentacle metallic connection made with a good battery with the install of the signal generator. The most important that the signal generator has good low resistant ground. The locator can then use them following the underground pipeline dielectrical short with the signal sufficient locator to follow with the signal across the dielectric. Consequently, the signal is followed through a dielectrical. The dielectrical is bad. If no signal to follow, verify the insulated flange tester. Shows your voltmeter 1 and 2 connections and reference electrode and temporary power supply, temporary anodes over 50 feet. 674. Using temporary local cathodic protection system. Install the temporary local cathodic protection system. Increase the current of the street side of the dielectric possible to merely increase the current level of the existing system. The temporary system should be installed with the current. Should the distributor location be tested, the potential measure of the bowl structure of the potential host side of the dielectrical remains approximately the same with the positive direction less negative. Potential street side of the dielectrical chain with the negative direction are not short of the potential measurement chain is more negative than its current increase the two structures shorted together. Casing test. Casing present unique, sometimes very challenging problem with corrosion control, although required with the complicated for the presence of the serious problem, the application for the cathodic protection to the carrier pipe. Not sure they may be shielded adequate protection short of the totally shield with the carrier pipeline with the cathodic protection, often large area of the pipeline. Preferred method of corrosion control, isolate sealing the casing when there is no electrolyte with the place between the casing and the carrier pipe. Fill the air with a non-conductive sealant casing normally bare with the carrier pipelines and or normally really well coated. The casing normally will have vent pipes on the other both ends of the testing station. Corrosion control testing. The test station usually has 4 wires, 2 casings, 2 to the carrier pipeline. There is no test station already installed. One should be installed prior to testing. A minimum, there is no metallic connection made to the carrier pipeline vent pipe that connected with the metallic to the casing. There's no vent pipe carrier test point in the vicinity of the casing. You must excavate the carrier pipeline or casing required for the testing connection. Again, with the test station should be installed. Figure 17 shows the testing, casing, installation, road and roadway, casing, vent pipe, test station, casing, and carrier pipeline. Caution: do not use an ammeter to measure resistance between the carrier pipeline with the case of the isolation good, but the current will flow with the media with the damage of the result of the current damage, not damage of the media with the measurement would indicate with the resistant value. Voltage when you interpret the media with the coming from the internal battery installed with the external electrical circuit being measured. 681. Testing casing cathodic protection on the carrier pipeline with potential measurement of the carrier pipeline casing by changing only structural connection without moving copper sulfide reference electrode. Figure 2 shows testing the shorted casing, show the voltmeter 1 and 2 reference electrode. If potential measurement is significantly different than over the 10 millivolt casing, not shorted pipeline under normal condition, carrier pipeline should be potential more negative 0.85 volt DC. If the casing should be approximately 0.35 to 0.6 and negative 0.65 of the DC of the difference between 200 and 500 millivolt. And 2 potential measurement of the non-significant difference on the 10 millivolt with the casing stored pipeline with additional testing required with an install of a temporary local cathodic protection system to increase the current of the carrier pipeline. If possible, merely increase the current level of existing system. Note that the temporary system must be installed on the opposite side of the railway or the roadway crossing with the location of the dental testing. Repeat total measurement of the carrier pipeline with the case and the potential of the casing remains approximately the same. The change of the positive direction less negative the potential of the carrier pipe and change of the negative direction of the installation good. Have both carrier pipeline and the casing potential measurement of the change with the more negative current is increased with the carrier pipeline is shorted in casing. Show the figure 19 show the testing shorted casing with a power supply, temporary anodes over 50 feet temp power supply, voltmeter, reference electrode. Or 682, testing casing without cathodic protection on the carrier pipeline. Install with a temporary local cathodic protection system applied with the current carrier pipeline. Install always installed with a temporary anodes opposite to side crossing with the side with a potential measurement. Or take a potential measurement of the carrier pipeline casing, changing only the structure connection with moving the copper sulfide reference electrode. Two potential measurements significantly different over 10 millivolt when the casing with a not shorted pipeline. Sufficient current applied with the carrier pipeline should have a potential approximately negative 0.85 volts, and DC with the casing should be between negative 0.35 and negative 0.65 volt DC. If two potential measurements are not significantly different under 10 millivolt, the casing shorted on the pipeline, additional testing is required. Increase the amount of the current applied with the carrier pipeline by turning up the power supply. Additional temporary anodes. Repeat the potential measurement of the carrier pipeline with the casing. The potential casing remains approximately the same in chain, but the negative direction less negative. The potential of the carrier pipe chain with the negative direction insulation is good if the bowl of the carrier pipeline with the casing potential measurement change more negative as the current is increased. The carrier pipeline is shorted in the casing. 6.9 testing for shorted between the two structures. Shortening between the two structures adversely affect the operation of cathodic protection. If the protection structure is designed to protect the isolated structure, the shorters other than structures normally result in loss of adequate protection. Structure shorts may also result in the current distribution being adversely affected with the consequently loss of the protection. Area of the structure determination short of the isolated with additions also important. The design phase cathodic protection installation preferred method of testing short between the two structures potential testing, and the method will normally intermediate with the indicator for the two structures if not short, but at the same time provide valuable potential data. Method of the potential measurement of the value verifies slightly cathodic protection is simplified. Or supplied with neither structure. One structure of the bolt structure with the power supply with the required with one bolt structure does not have cathodic protection. Solve if one of the structure has cathodic protection. Refer to the procedure recommended. If the both structures have cathodic protection, refer to the procedure recommended. Caution. Do not use the anemometer to measure resistance between two underground structures. If the structure is isolated, the current will flow with the meter, but the damage result with the current does not flow with the damage. The meter, the measurement will indicate a resistant value. Voltage would interpret it with the meter as coupling with the internal battery installed with the external electrical circuit being measured. Alright, 691, testing is short between the two structures with the cathodic protection. One structure to take the potential measurement of both structures, changing only the structure's connection with moving the copper sulfide with the reference electrode. Show the testing station metallic contact voltmeter reference electrode structure with cathodic protection, structure without cathodic protection, testing station metallic contact. Figure 20, testing is short between two structures. That was figure 20. If two potential measurements is given the difference with the 10 millivolt with the two structures non-metallical shorted together with the normal with the condition structure for the cathodic protection should be presented with a more negative with 0.85 volt DC. Steel structure without cathodic protection should be with approximately 0.35 negative and 0.65 volt negative. Difference of 200 to 500 millivolt with the other structure with the copper steel concrete under normal conditions should have the potential between negative 0.2 volt 0.3 negative 0.3 volt DC. Two potential measurement not significantly different with the 10 millivolt with the two structures short of additional testing required by the install of a temporary local cathodic protection system. Increase the current to be carried with the pipeline possible to merely increase the current level of the existing system. No temporary system should be installed, but the current should be to distribute the one structure repeat with the potential measurement of the both structure with the potential unprotected structure remains approximately the same with the chain with the positive direction less negative than the potential for the protected structure chain with the negative direction. They are not shorted both potential measurement chain with a more negative as the current increase with the two structures shorted together. Alright, this shows figure 21 shows the testing is short between the two structures of the power supply, temporary anode, temporary power supply test point, voltmeter test point 2, reference electrode structure with cathode protection, structure without cathodic protection. Alright, 692 testing the structure between the two structures of the cathodic protection bolt structure. Take a potential measurement of both the structure of the chain only with the structure connection move with the copper to copper the 12 of the reference electrode. If two potential measurements is significantly different over the 25 millivolt with the two structures that are non-metallically shortened together with the normal condition bolt structures, show the potential more than negative 0.85 volt DC. Two potential measurement of non-significantly different under 25 millivolt. Two structures may be short with additional testing is required. If one of the both are protected structure with the head and the current with the turn off of the rectifier in one system and repeat the potential measurement of both structures. If the potential of the structure of the rectifier still remains approximately the same with the chain with the negative direction with the potential structure of the rectifier off changes because of the direction with less negative not short with the both potential measurement chain with the more positive approximately the same magnitude of the one system current with the interpreted with the two structures are shorted together. Figure 2 shows the testing shortage between two structures of cathodic protection both structure. Cathodic protection with, structure without. They both have structure with cathodic protection. On-off rectifier 1 and 2, test point 1 and 2, voltmeter rate, reference electrode. Table 2, expected potential examples of shorted, non-shorted conditions show that the rectifier 1, 2, and system 1 and 2, system shorted, system condition, expected potential, system not shorted, interfere, rectifier 1, 2, system 1 and 2, system not shorted, interference, rectifier 1, 2, system 1, discharge, system 2, pickup area. Both systems have impressed output current. System with clear indication of short condition should be identified. Repeat the test procedure, leaving the first system rectifier on an interpreting system. Second system rectifier, its potential. Structure with the rectifier still remains approximately the same in the chain with the negative direction potential. Structure with the rectifier chain with the positive direction, less negative than short of the both potential measurement of the chain with the more positive, approximately same magnitude with less negative, with only one system current is interrupted. Two structures are shorted together and both systems have impressed the current system clear indication shorted condition has still not been identified. Turn off both rectifiers. File procedure recommended. 693. You're testing shorting between the two structures without cathodic protection in either structure. Take potential measurement of both structures. Change only the structure connection without moving the copper-to-copper sulfide reference electrode. Test station metallic contact. Voltmeter test station metallic contact. 2. Structure without cathodic protections. Testing between short of the two structure cathodic protection either structure. And 2. Potential measurement is significant between negative over 25 millivolt. The two structures non-metallic shorted together under normal conditions. Steel structures have potential between approximately 0.35 volt DC, 0.65 volt DC. Structure copper, steel, concrete under normal conditions. Potential should be between negative 0.2 volt DC, negative 0.3 volt DC. Structure galvanized, zinc coated. Potential should be between negative 0.8 volt DC, 1.05 volt DC. If two potential measurement is not significant under 25 millivolt, two structures may be short. Additional testing required. Install the temporary local cathodic protection system to apply current to one of the structures to be installed, where the current should be distributed equally to both structures. Read potential measurement of both structures. The structure with the current being applied with remains approximately the same chain with the positive direction. Less negative potential structure with the current applied with the chain with the negative direction. They are not shorted. If both potential measurements are changed with the more negative as current is increased with the two structures are shorted together. Shows the reference electrode test point, voltmeter test point, structure without constant cathode protection, structure 2 without cathode protection, temporary power supply, anodes. Alright, 610, current requirement testing procedure. Current requirement testing conducted with the playing with a cathodic protection system installed with the turn of the tab of the side of the system. Required with the system that does not design requirements of insulation structure to be protected with the isolation must be accomplished prior to the current requiring testament. Current requirement for the non-isolated structure does not give an indication for the current requirement would be structure where the isolated with the temporary system or to be used to determine the effect of the current applied with the potential structure being tested to actual protection not to be accomplished estimate with the amount of the current required point. Both rectifiers should be used together with the temporary anodes, usually ground rods, existing metallic structure to improve the testing current of the structure. Vehicle batteries can be used where as well as spare rectifier with DC generated DC welding units rectifiers from other systems temporarily removed from the use. 610.1 Temporary local cathodic protection system. Temporary local cathodic protection should be located in the area that is intended. The installation is located with known, if not unknown, located as remote possible from the structure to be protected without any foreign structure in any area with a temporary anoid bed, with any foreign structure between the temporary anoid bed and the structure to be protected. Warning not use any metallic structure for the temporary anoid is shorted to the structure being tested will result of large current surges that can cause injury to personal damage of equipment for Navy projects conducting the work on near circuit. Energized lines, parts of the equipment operating to above the 50 volt within utilized with practice with identified Op Navy P4511698. Alright, 610.2, the existing metallic structures. Existing metallic structures such as the metal fence, culverts, abandoned pipelines, abandoned wells can be used with a temporary anoid supplement and install the temporary anoid's existing structure to be used short traverses with the structure shorted with the structure test bed, the area with the temperature install short with a scale with determine if any possible temperature anoids exist and any foreign extra structure and is in the air. Do not use pipeline tanks, temporary anoids that would conversely affect if the leaks occurred. 610.3 temporary anode. The number of temporary anodes required depends on available the voltage over the amount of the current desired of the resistivity of the swivel. The number of the anodes is double. The amount of the current is approximately double the swivel. The resistivity is double the current of the cutoff. The very low resistivity swivel of the 2-3 anodes may be sufficient, but the very high resistivity swivel of the high number of temporary anodes may be required. The amount of the current desired depends basically on the quality of the coating of the structure being tested. The very well coated structure will exhibit a noticeable potential change with a small amount of the current 1 to 2 amps. A poorly coated structure will now exhibit the potential change except for the large amount of 10 to 20 amps. If the voltage is double, if the current is double, the consequently the voltage source is low, the more temporary anodes will be required. If the voltage source is high, only a few temporary anodes will be required. Alright, 610.4 installation of temporary anode system. Installation of the temporary anode system is often required for the form current requirement testing, normal current requirement testing. Aluminum copper grounded rods used with the metallic ground rod can be used as well as the metallic pipe, the conduit, the steam pond, river, lakes, bays, oceans, other standing water in any of the tamponade and temporary anode location may be the ideal location between low resistance to earth anode bed. If the wet location of the ground rod can be simply laid in water. Normally, ground rods are cut in half to make 4 to 5 foot sections. These ground rods metallic pipe with the continuity are sharpened and driven into the ground approximately 0.3 meters or 1 feet above the ground level. These rods shall be installed with approximately 4.5 to 6 meters apart, lower resistance to the earth and high resistant air. With the high test current with the required water sprinklers can be used with a period of time. Low resistance to the extreme case of the excavation can be made. Small diameter steel pipe can be pushed in the earth and then backhoed bulldozer. The method can be used to simulate with a deeper insulation possible. Install 9 to 18 meters into the man with a non-rock formation. Caution, not connected with the structure that being tested for the positive of the terminal of the power source of the corrosion of the structure may result. Alright, 610.15. The temporary anodes must be connected with the power source of the positive terminal structure being tested to connect with the negative terminal. Physical strength, low resistance, number 6 AWG copper cable, larger, more may use 2 AWG, the greater desired. Expressly longer than either structure of the anode cable is needed. Connection may be made with the pipe clamps for the test clamp, sufficient size split bowls, exothermic welding. All wiring connections must be made to accommodate the voltage current required for the testing. Normal portable rectifier 60 volt to 30 amps is 30 volt to 60 volt. 30 volt to 60 amps. Other rectifiers may be 180 volts or 100 amps. 610.6. Before applying power, before any power is applied, the essential obtainment of the potential data of the structure of the native potential must be tested for all locations. Tested during the current requirement of testing obtained with the potential shift accomplished by the test current. 610.7. Applying power, being a low voltage setting, the term power ensure the potential shift of the structure of the negative direction, generally increase the voltage current, desire output, periodic changing potential to ensure corresponding negative shift of the current, increase the maximum voltage reached, and the more current is still required, turn system off, supplement temporary anode bed. 610.8. Sufficient current. Sufficient current is applied with a substantial selection structure that has been tested to achieve the noticeable potential shift of when the full protection achieve the full protection achieve the current requirement obtained with the test current. Full protection is not achieved the further calculations are required. 6.9.10. Calculating current requirements. Once the potential shift is certain with the current to get with the shift is known, but the current requirement can be calculated. Current is double the potential shift is double the current distribution. It should be considered. Good current distribution achieved. The simple mathematical formula will achieve the current requirement. If proper current distribution is not achieved, it must be designed with the system. Design will call for the deepening anode bed with the current requirement of the estimate with the calculation of the design for the surface bed for the anode. An additional cathodic protection system should be considered for the further current requirement of testing additional locations conducted. 610.10. More than one anode bed. With the current requirement that you can test include more than one anode bed location. All current sources should be interrupted simultaneously. Measure the potential shift of the structure for the total current or requirements found. Adding the current power source together that all consider the proper current distribution. Estimate the required current requirement of individual system. 610.11. The completion of the testing. Applying completion and testing, turn all power sources off. Disconnect all the cables to remove the temporary anodes for easy removal of the ground rod, small diameter pipes and conduity. 3 flat metal bars are shown in figure 25. Figure 25 says remove the temporary anodes. 1, 2, 3. 1, 2, 3, 4. 611, and then we're going to cut the tape there. Page 61. Electrolyte resistivity measurement taken to determine the coupling proper system operation. 611.1 4-pin method.